Our first lab is a measurement and functional relationship between variables. So if you go in the home page for your course in the Canvas, you can see this lab here. Uh, Click here and then you will see a link here, and if you click on this link, you should be able to download a PDF file, and the PDF file uploaded here is a fillable PDF file. So please uh, try to if you want to work this file, this PDF file work properly, please download Adobe Acrobat PDF reader, Adobe Acrobat PDF reader, and open it with Acrobat. And if you see here, you can fill all this file, all this input, all these spaces here. For example, if you want to complete this table, you can just input numbers here like this, and you can complete the table using this PDF file. And if you don't want to do this way, I am also open that you can just download it, and if you have access to printer, you can just print the PDF file, and so just complete it by hand using a pen or pencil, and once you are done, you scan the whole file and convert it into PDF files. You can use as softwares like OneDrive or Apple Notes if you have iPhone, or you can also use Cam Scanner, all these free softwares to convert the files to scan the document and convert it into a PDF file. So with that, let's start talking about what this lab is. So this is a functional and measurement and functional relationship of variables. So basically, when we are doing experiments in science, when we perform experiments, generally what we do is we change one of the parameter or variable and observe the effect of that change in another variable. The variable or the parameter which we change is generally called independent variable, and the parameter which we will observe based on the parameter we just changed is called dependent variable. As the name suggests, independent variable is what we will change, and dependent variable is what is changed because we change the independent variable. In other words, dependent variables depend on independent variable. And in most cases, when we have this independent variable and we change this independent variable and observe the effect of independent variable on the dependent variable, what we do is we collect data for each pair of independent variable and dependent variable, and we use that data to create a mathematical equation, or we also called it a function, and that will create a relationship between independent variable and dependent variable. So in other words, using the experimental data, we can establish a relationship between independent variable and dependent variable. So one easiest way to establish this relation is by linear regression. And in order to do a linear regression, the best way or the simplest way is to draw a best fit line using a simple graphical method. So whenever we are performing any experiments, the data we collect are generally prone to errors. So the error can be a manual error, a measurement error, and so on. There are so many different ways the data can be data can be wrong, or it is not collected properly. And in order to reduce the error while collecting data, the it is a best practice to actually tabulate the data immediately. As soon as you start collecting data, you should create a table and input all the data as you collect. And you should also remember to use proper units, so you don't have to so you can remember all the units used in the system, so you can convert it into different units if you have to. And you should also organize all these columns with columns in sorry all this data in column forms, row and column forms, and to form a table. And once you collect the data, you can plot the data. There are different graph papers. For example, the one we most commonly used in our day-to-day life is a linear graph. There are also a graph called semi-log graph or log-log graph. You can we can use all these different graph papers based on how our data is to create a plot. And when we plot data, uh, generally not generally how we want to plot is that we will want to cover as much area of a graph paper as we can without stretching the data. For example, if you when I say stretching, for example, let's see, I have a slope something like this, where this is at 45 degree. If my graph looks like something like this, we can say this is around 45 degree, right? But if your graph is extended in x but short in y, in other words, your x-axis is scaled but your y-axis is small, then the same graph would look something like this. And if your graph is like this, the same would look something like this. So in order to avoid this kind of scaling effect in a graph, we should always try to uh, adjust the x-axis and y-axis properly based on the data we have. And we should also try to cover as much as we can in a graph paper, so the graph is readable. And once you figure out the scale for the graph, we will distribute all these numbers properly to cover all your minimum to maximum data point. And since we are trying to establish a relationship between two variables, instead of plotting a line graph or curve, the best graph we will plot is generally what's called scatter plot. So what this does is this will just plot our coordinates as a point, and it will scatter uh, in the plot. So if you are instead of plotting by hand, for example, if you are using Excel to create the plot, you can use scatter plot to create the graph. And once you have all this figure out how what you want to plot, all the scales for your graph, etc., you should also uh, name your axis properly. You can see here, this is x-axis label, y-axis label, and this is title. So you will want to put both name and unit for all your axis labels, and you will also want to put a title on the top, so it's easier to understand what you are plotting. And one thing you should remember before moving forward is, for example, if you see here, uh, the y-axis of this plot is dependent variable and x-axis is independent variable. So uh, for example, if you let's say you are collecting data, and let's say you are calculating uh, distance covered based on the velocity of an object. Let's say you are changing velocity and calculating distance for each time interval, like this. So basically you are changing velocity, and based on the new velocity you will get a new distance covered by an object for a particular time interval. So if you look at here, this will be independent because you are changing the velocity, and the distance will be dependent because the distance is changing with respect to velocity. And when you draw it like this, and how we talk about it is, when we want to plot it, what we will say is d versus v. So we will say plot the graph where plot the d versus v graph, or distance versus velocity graph. So if somebody told you to plot y versus x graph, how you want to plot is, your first variable here will be plotted in y-axis as a dependent variable, and your second will be independent and you want to plot your independent variable in x-axis and dependent variable in y-axis. So later on in this lab, I will say you have to plot t versus l. So basically what I am saying is t is our dependent variable and it will depend on l. So you will be plotting t in y-axis and l in x-axis. So once you have all this scatter data plotted, your axis labeled, your title labeled, what now is the time we will generate the relationship between dependent variable and independent variable. So one best way to do it is to draw a best fit line. So when we say best fit line, this is a straight line or sometimes curved line that will uh, be closest, approximately closest from all the data points. In other words, the straight line that will fit all these data points as close as you can fit them. Since we are doing it manually, we are not using any statistical method, so your answer may be different from some other students. It's not exact numbers, so don't worry if your answer is little bit different. So basically what we want to do is we want to draw a straight line that will fit as many data points as you can. And once you have a straight line, if you remember from high school, the equation of a straight line in slope intercept form is given by mx plus b, or sometimes it's written as c. Here y is dependent variable, m is the slope of the straight line, x is the independent variable, and y is the y-intercept of the line. So this x and y are the variables we are creating the relationship, and this slope and intercept is what we will get from this graph. And the the slope is defined as the rise over rise over run from the graph. We can see here how to calculate the slope. For example, once you have a straight line, you will take 2 points randomly on this straight line, and then you will calculate you will figure out the coordinate of those 2 points, right? Once you have those 2 points, basically what you will do is you will calculate this distance versus this distance. You will calculate this distance. So this is basically, if this is x2, this is x1, this distance is x2 minus x1, so this is run, and this distance is whatever this point is. So this is y2, this is y1, so this particle distance here is y2 minus y1, and this is rise. So our slope is rise over run, and rise is y2 minus y1, and run is x2 minus x1. So using this formula and calculating the rise and run, we can simply calculate the slope of this straight line. One thing you need to remember is we are calculating the slope of the best fit line, so do not use these points which you plotted. Do not use those points, because those are not the straight line. So what you want to do is you wanna pick random points on this line and use them as your x1 x2 and y1 y2. And one more thing here, the y-intercept. The y-intercept is where for example, if you extend this curve here, so wherever this line will cut your y-axis, that value will be your y-intercept, or in other word, y-intercept is the value of your value of your dependent variable when your independent variable is 0. So in this way you can calculate both slope and intercept, and once you have this slope and intercept calculated, you can create the relationship between dependent and independent variable. So in order to collect the data, we will use a virtual simulation created by PhET. We will use this lab to generate data. If you click on this link provided here, it will open this if you click on this link, it will open this simulation. So go to this intro, a pendulum lab, and we can see here we have a pendulum setup here. So we will use this pendulum to collect data. So there are different variables you can change in this pendulum. Sorry, different variable you can change in this simulation. For example, if you look at here, we can change the length using this slider, length of the pendulum. We can change the mass of this bob or ball, and we can also change gravity, but we stick to Earth's gravity for now, and you can also change the friction on this hinge, changing the damping or how fast the oscillation will die out. But for this lab purpose, we will leave it at 0. So these are the most common variable, sorry, these are the variables we can change in this simulation. And we can also change on the angle. If you see here, we can see these angles. uh, let me just pause it here. So we can change this angle by dragging it. So this is another variable you can change. For example, you can start the swinging of pendulum at this angle, or this angle, or this angle, whichever angle we want. And there is this ruler as well, which we can use to measure the length. For example, here, like this. And whenever you are collecting the data for the experiment, you have to measure the distance from this 0 point to the center of the bulb, not at the upper edge or lower edge, rather you have to collect the distance from the hinge to the center of the bulb. And one more thing is, you need to learn how to use this stopwatch. So if you go in this left bottom corner here, you can turn stopwatch on. Here you can just click it here and drag it wherever you want here. And if you want to, so basically let's look at the lab first. So what we want to do is, we want to swing this pendulum to and forth, and measure the time taken for this pendulum to swing back and forth. The first table here is basically asking you to play around in asking you to explore different variables that we can change in this simulation. For example, we can change the length, right? We can change the length, and you will you can do this simulation here and observe like what happens when you change the length. So that table is basically asking you what these parameters do, what will happen when you change the length, or from when you make the length longer, or when you make the length shorter, what happens to the time period, right? And time period is time taken for this pendulum to swing one to complete one swing. And the when we say one swing, for example, if I start from here, uh, if I let it go, one swing is the time, one swing is basically from here, it goes here and then comes back to this original position. So that will be one swing. For example, I started at 40 degree, so it will go in the other side and back. So this is one swing, and the time taken for this one swing is called a time period of the pendulum. So once you observe effect of this variable, for example, you can also observe what happens when you, instead of swinging from a 40-degree angle, what happens to the time period when you start swinging from 25 degree. So is the time period increasing, is the time period decreasing, and when you change the length, is the time period increasing, time period decreasing. And if you change, for example, mass, what happens, is the time period getting faster or slower for the same case. So basically you will observe, you will explore the simulation and write it here. Your variable is, for example, length, and you will explain whether the time period is reducing, increasing, and so on. And for the second part, basically what we will do is we will use the stopwatch to measure the time taken for 10 swings for 8 different lengths. So remember, the variable we will change by ourselves is length. So that means the dependent variable is the time period and the independent variable is length, because this is the variable we are changing, and time is the variable that's changing because we are changing the length. And if you look at here table, so basically we will leave the angle fixed. We will use 20-degree angle and swing this pendulum 20 times and calculate the time taken for 20 swings. So this is how we will do it. For example, let's see here. We want a fixed length, angle. So first we will stop it. If you click on here, it will bring back to original position. So you will measure the length from hinge to the center. It's around 40. So if you go back to your table, so our length is 40. Sorry, the length here is in the table is in meters. So let's see what is in. This is in centimeter. So this is 40 centimeter. So 40 centimeter is 0.4 meter, and then we will swing it for 10 swings here. So we will reset this stopwatch, then start the stopwatch, bring the bob at 20 degree, and then start swinging for 10 swings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you see here, it took 12.75 seconds to complete 10 swings for me. So number of swing is 10, and it took 12.72 seconds. And if you remember, we defined a time period as time required for one swings, and the data we collected here is for 10 swings. So our time period will be 12 over 12.72 over number of swings 10, and the formula is also given here, total time over number of swings. So this will be 1.272 seconds, and this is just period is squared, which is basically this number is squared. So uh, basically 1.272 times 1.272, so 1.617. So basically you will repeat this for 8 different lengths between, and keep the length between 0.1 to 1 meter, and repeat this for 8 different numbers. Once you collect this data and complete this table, you will plot all these data and we will observe whether this relationship we can draw a straight line or not. So when we talked about drawing a straight line, we assumed that the data were approximately linear, or in other word, we assumed that the data can be represented by one single straight line. Sometimes that's not true. For example, let's see this data here. Let's say I have a data here and I want to plot it. Let's see, mm, here. So my x-axis is pendulum length, y-axis is time. So like this. So you can see this graph is not actually a straight line, rather it's you can see this is kind of like a curved line instead of a straight line. So if you plot t versus L, if you draw a straight line instead of a curved line, your data will have more error, meaning you cannot represent this kind of relations by a straight line. And however, uh, if you were to make decision based on this graph versus, for example, let's see another graph here, where I would plot pendulum length versus sorry time square versus pendulum length. Now if you see this line, this is a very straight line, right? So we know we can represent this data by a straight line, not by a but not this first curve by a straight line. So this is basically what this is here. You will start plotting first t versus L, and in general, if the line is not a straight, the decision making, for example y equals to mxc, the relationship between two variables is not straightforward, and you cannot interpret much information from it. And what we want to do is we want to convert those data into a straight line like we see here. And how we can do is sometimes we can just change the variable uh, in our graph. So if you see here, first we plotted time versus length. Now if you use the same data, calculate a time squared and plot t square versus length instead of a curved graph, now you will get a linear graph. The benefit of converting converting a quadratic graph into linear graph is that the relationship is very intuitive and easy to interpret. So in different cases, you want to convert your non-linear graph into linear to make it easy to interpret. So basically that's what we will do. We will first plot t versus L, and then calculate the t square value, and then plot t square versus L, and we will use this second graph to calculate the to create a best fit line and calculate the slope y2 minus y1 x2 minus x1, right? That's pretty much and if you have access to printer and you prefer to print a hard copy, I have included this graph papers here for two graphs. First plot t versus L, t square versus L, and calculate the slope for the slope and intercept for the second graph. And if you don't want to do that, I have also included a fillable graph here. What you can do is go to Excel, input all your data, plot the data, and if you want to add a trend line, let me redo it. So you can also have, if you need help on Excel, how to plot the data, you can refer to this. So how I generally do the plotting in Excel is, first I go to insert, then insert charts, select scatter. The first one here without any line is the scatter plot. So it will put a empty image, empty graph here. So right click, select data, and then you will add data here, add, and then this is series name, which is not important if you are just plotting one line. If you have multiple data, then this will become important. For us, we are just plotting one graph, so I will just ignore it. And then this middle section is x values, which is your values you will use in x-axis. So click on this arrow here, then it will open this. For us, the length is the x-axis value, and then click y-axis value, and then you can use enter, OK, and once you are here, click on OK. Now we can see our graph is here, and you can also see on default you will have a chart title but no axis title here. So if you want to add axis title, click on this plus bottom here. So if you click on the graph here, it will show this option. So click on plus, and then from here you can add axis title. So if you click on axis title, you can see now we have axis titles here. And if you want to change this axis titles, all you have to do is double click it, and it will let you edit the graph. So our x-axis is length, and you should also include a unit like this, and y-axis is period, and this is in second. The title of this graph is T versus L. So now we have axis labels, titles, and if you want now we want to create a best fit line, right? So in order to do that, click on plus here, then you can see a trend line in here. So if you click on here, we can see a best fit line here. And in order to calculate slope, pick a random point here somewhere, just randomly, approximately. And if you see here, this is your x value is around 5.6. so x value is x1 is 0.56. Your y1 value is where we were looking at here is around 1.5. so y1 is similarly. Let's pick a random point somewhere. Let's say here. So x value is around 1.8, y value is around 2.7. 1.8, 2.7. So this is x2, y2. So now we have both x1 y1 and x2 y2, and we're using this we can calculate slope using y2 minus y1 over x2 minus x1. Right, you can use this to calculate the slope of this graph. And once you have calculated this slope, you can also compare this your number with the Excel calculated number. So in order to do that, click in this button here and click on more options. Then go in at the end here, you can see display equation on chart. So click this button. Now we can see this equation here, and if you look at this equation, this is in the same format as y equals to mx plus c. Here y equals to this number is m, then x plus this number is y intercept, and you can compare your slope calculated from here with this slope. Now if you printed a hard copy, it's easy. You can just you you can just plot it in the physical paper and scan it. But if you didn't do that, and if you use Excel like me here, you can in order to submit this graph, what you need to do is save this image. For example, I will just save it here in download, right, and go back to your Excel, the PDF file here, and then go back, go at the end. Here there's an option called uh, plot 1 t versus L, and there is a image handle here. If you click on here, it will let you browse your computer to upload a figure. So go here, and then if you click on here, it will let you upload the curve, and then do the same for second graph, and you can just save it. Now your report is complete, and you can submit this new saved file in Canvas. Or one thing you need to remember is just here I was able to easily upload image here, right? So if I click here, it will simply open it. But if you don't have Acrobat and you are, for example, using Chrome or uh, Microsoft Edge or Firefox to open the PDF, sometimes you will not be able to uh, do it. So that's why I'm asking you to use Acrobat instead of all these other different browser. For example, here I'm opening it with Microsoft Edge. Here I can easily edit these tables. I can put numbers here, but if you try to upload image, it will not open the options. So uh, I, 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 I recommend you to use Acrobat PDF reader to complete the fillable files. Once you are done with files, go back to Canvas, start assignment, and then go to text entry here and write a quick summary uh, summary of your results here, and then file upload, select file, and then you can just upload your PDF file, and that's pretty much and then submit your assignment, and that's all you have to do for all the labs for different all the labs in upcoming weeks.